As I gave you some, okay, this is also a serious problem. So let's say if you are from industry, you can separate these words. Okay, these are the possible issues. Are you familiar with this? Are you aware of these things? If not, let's just explore. Right. So this is how the systems or things have been evolving. Always academics do lots of research and suggest, okay, these are the issues, these are the things. If you wish, you can integrate. Alright. So this is how, I mean, all those things that I mentioned clearly. This is again summary. So if you agree, I can give you a little bit on quantum actually. ये जो मेरा main area है. Okay. So the next breakthrough in AI is the quantum computing actually. Even AI and the quantum, they both are going to do. So AI for quantum and quantum for AI. So quantum AI combines the computing principle with artificial intelligence capabilities, while the traditional computers uses 0 and 1. And the quantum computer uses the qubits actually, another powerful method of representing the information or abstraction of the information to the qubits. And these properties, specifically, let's say, these qubits can exist in simultaneously either in the, or in the form of superposition. Superposition is one of the key aspects. Superposition is one of the key aspects basically in this quantum processing. So here, and it brings the power of computing basically. As a result, this allows the quantum computers to perform certain calculations exponentially faster. As I mentioned, certain calculations can be done much faster than the classical machines. And there are so many companies like Microsoft, Amazon, Google, all they are working to develop these quantum computers. You see. So maybe now look at this simple picture actually. Is the engineering, I mean, we can think of a classical machines. I think 70 years ago, the classical machine used to be having quite big, something similar to the size of this room, right? Classical machine. NIT. Now सुना? अब ये तो 6th standard के बच्चों को पढ़ाने लगे हैं ये कंप्यूटर. कैसा सा कंप्यूटर? So that was the computer NIT called big machine. आज जो कंप्यूटर हमारे मोबाइल पे रखा है या सॉरी टेबल पे रखा है वो 70 साल पहले कुछ ऐसा दिखता था. Can you imagine? 70 years ago ये जो मोबाइल है हमारा ना वो उससे कुछ इस तरह का था. Mobile is so powerful on computer, right? So it took basically 70 years or even more from this to this. Say. Now we compare the same thing with the quantum computer also. So the quantum computer is also quite big nowadays. So to reach to some scalable level, it will take again some time actually, maybe 30, 40 years, 20 years, something like this. And if you see very interesting observations here, the speed, size, cost, durability, technology, use cases, power. So the power, if I say, earlier the computer used to take kilowatts. Right, and even the quantum computer also takes tens of kilowatts. If we talk about the reliability, these computers are quite fragile. I mean, they are based on vacuum tubes, and vacuum tubes used to be quite fragile. They need to be often replaced, changed. So something similar with this also, quantum machines also. Speed, application, actually if you look at the application also, this classical machine that time was designed mainly for defense applications. Can anybody guess what was the purpose of this computer initially? It was mainly used by the defense for estimating the projectile motion. So this machine was mostly used for this purpose. in the World War II. And something similar, today also the quantum computers are mainly used in the defense purposes. So this technology is, something always niche, as I put. So, but in future it can be scaled down and it will reach to the masses or something better. So ये मैं थोड़ी देर के लिए quantum information को छोड़ देता हूँ. ये फिर आप लोग बोर हो जाएंगे, I think. So this is how the quantum computer looks like, say. And I can ask you a very simple question. Imagine that tomorrow you have a quantum computer on your desk. What would you think of? क्या करना चाहेंगे आप लोग? अगर कल क्वांटम कंप्यूटर आ जाता है हमारे पास तो yes, right. So the question is out there actually because most of you. So I got some of the typical use cases here where these quantum machines is quite useful. So would you design a new vaccine? Designing a vaccine takes a long time actually. Or designing a new drug takes a long time. And this quantum computer can cut down that time significantly. So from few years to just 1 or 2 years, let's say, or depends, something like this. Because it is quite good in finding some best optimization very quickly. Then the next is the financial trading algorithms. ये आप लोगों ने सुना हुआ ट्रेडिंग algorithms? है? सबसे ज़्यादा कैंपस प्लेसमेंट होता है किसको मिलता है? इन सिंपल बात करें तो अगर आप न्यूज़ में देखेंगे 4 करोड़ रुपए का पैकेज इसको मिला, 2.5 करोड़ का इसको मिला, 500. Good. So you can build some new algorithms where you can make money even just with a small spike. Right?
स्टूडेंट लोग कौन सी है? बीटी फर्स्ट ईयर आप सेकंड ईयर में.
So this is the
आप सेकंड ईयर में जाएंगे.
We can design some new kind of algorithms, trading algorithms. Then finally,
हमारे साथ ही
the digital trust. So digital trust either it is a DMS or anything actually, or your cloud or machine. So will you try with your digital trust? So for example, tomorrow you can have password of everybody in your pocket. If you have a quantum computer, easily you can break anybody's bank account, so you can get into that. Even you can collapse the entire digital infrastructure if you have those things actually. So this is the power of this quantum computer actually. Let me tell you. Yeah. So I think so blockchain technology is again based on RSA and AES algorithms. So blockchain technology is also quite vulnerable to these quantum machines in simple statement. And now the people are also moving to make those blockchains quantum resistant. Blockchain also quantum resistant. So they are replacing their underneath algorithms through quantum resistant algorithms. And once they replace them, it is okay. So there is also quantum safe. So, if any question related to this, because I am moving this talk from digital or BMS to your quantum business. So now, how the problem really comes actually? Let's say either it is a BMS or any safety or anything actually. Why the problem is this? Why this quantum computer or why this public key platform? PKC is public key cryptography here. Why it threatens? As I gave you a simple example. Let's say if I am having a product of 2 numbers, prime numbers. So generally your public key is connected with these 2 numbers, let's say, and the product is available publicly. Right? Product, let's say product of 2 numbers. 2 large prime numbers is publicly available. And one secret number is with you. So for you it is easy to find the another one number. But someone who is only having a product and let's say for example 81, yeah, something. So finding those two prime numbers is a challenge, even for a small number. But with this quantum computer, it can be done very easily actually. So that's why the problem actually. So anybody can have their secret keywords. So this is the main problem actually. So it is just again, since most of you are from the BMS or batteries, so this question looks irrelevant to you. But how many of us believe our current encryption will still protect the public key infrastructure or digital trust in 2023 or something else? So usually, basically, according to, let's say, if I give you some idea, then the 2030 is considered to be the year when we need to move or migrate to the quantum safe solutions. This is what the US and other countries have advised their governments to get ready or get prepared for these quantum safe systems. What if someone today is quietly recording all your communication feeds to decrypt them later? This is another issue actually. Like in your WhatsApp, let's say, or even BMS का connect कर सकते हैं आसानी से, you can easily link this security aspect. So you can easily link basically your BMS or any system actually. So so when we communicate through WhatsApp, or when my car communicates with your cloud, let's say, or your EV communicate with cloud, somebody is basically intercepting all those information. Just they want to pile it up. And with the hope that tomorrow I will be having a quantum computer. And then I can just easily see कि क्या चल रहा था, क्या डेटा जा रहा था, क्या डेटा आ रहा था, what was happening. Alright. So this problem is called harvest now, decrypt later. A serious problem in critical infrastructure, a serious problem to the defense or government agencies, because for our WhatsApp node is entrusted, right? Hello, good morning, ऐसे वाले मैसेज होते हैं या फिर जो भी है. So people won't be serious, or they are not interested unnecessarily. But there are lots of serious communication is taking place. So there are lots of bad adversaries or some actors, malicious actors. They are just intercepting or storing that information with the hope of having a quantum computer sometime soon, and then tomorrow they can easily problem कर सकते हैं. Yeah, we need security. In सब चीजों so this is what I started with this DMS की अगर communication हो रहा है और अगर आपका EV के साथ communication हो रहा है, sensor fusion का अगर communication हो रहा है, and everything is, let's say, somebody is intercepting or maybe somebody is injecting also. It can be both intercepting and injecting. So somebody is injecting some malicious information.
जरूरी है करना.
हाँ, data fusion में problem आती है. हाँ, ये data fusion कौन सी कंपनी यूज करती है? हाँ, डिजिटल फ्यूजन, सॉरी, कोई कंपनी यूज कर रही है इसका? हमें नहीं पता. तो सर पूछ रहे थे, तो बता देना यार, किसी को कहीं से पता चल जाए तो.
बाजू में बैठा है वहाँ पर है.
कौन? मैं ईवी ओनर डाउनलोड करेगा. ईवी ओनर
बैठा है वहाँ पर कमेंट कर रहा है.
हाँ भाई, तो वही हम करेगा ना. वो भी नहीं करेगा, वही हम कोई करना पड़ेगा, क्योंकि उसको अपना बनाना है. हाँ, महेंद्र कह सकता है कि आप डेवलप दिस सॉल्यूशन. But digital will also be secure actually. Yeah, this is what actually. So digital is correct. Yeah. So everything the code goes down. Security is. So that's why I'm just taking the security to the next level, quantum. Okay, I'm taking to the security to the top level. Yeah. Basic. Yeah. So classical security is also fine, because these, especially if you talk about these BMS, they are, quite resource constrained devices. So there we cannot put a large processors. Let's say अगर मैं कोई i7 processor लगाना चाहूँ, so we cannot put that, otherwise the cost will go high actually. And for that again we need to have some algorithms. They can be run on some resource constrained environment or devices.
सर अगर इसमें सिक्योरिटी ब्रीच होता है क्वांटम कंप्यूटिंग से तो अपन से डिटेक्ट कर सकते हैं मतलब कहाँ से हुआ
नहीं कर पाएंगे डिटेक्ट एक्चुअली, वो तो इंटरसेप्ट कर रहा है कोई भी. I will show you with an example also. इसी में. Then there is one more problem actually. If every digital signature in our securities ecosystem, every digital signature in our securities ecosystem, securities is that another securities actually, like SEBI, Security Exchange Board of India, SEBI kind of thing, securities ecosystem could be forced in one day. What would that do to market trust? So let's say I'm again doing some trading with my digital signatures, and if the digital signature is forced, then you can imagine the same problem. And it can be forced later also. So let's say today I bought some bonds, and then 2 years or 3 years down the line, that digital signature is forced, and someone else can claim this is my bond actually. Then you can see you lost everything. So we need to prepare for these kind of problems actually, and they are not very futuristic, but they are very close. खास करके ये जो बच्चे हैं ना, you should also, स्टूडेंट को अच्छे से पढ़ना चाहिए कि these are real challenges, security, right? So now simple question. Yes, को मैं छोड़ता हूँ. ये बड़ा इंटरेस्टिंग है इस slide. So there are two quantum computers. या फिर यहाँ से बात कर सकते हैं. So generally there are two types of algorithms. All your security is based on these two algorithms, RSA and DCC जैसे मैंने बताया था. And these RSA and DCC algorithms can be put into compartment, asymmetric and symmetric. And these are the strengths. So if you see the strength of the asymmetric key is almost 0 according to Shor's algorithm. So there are some quantum algorithms that is called Shor's algorithms. और Shor, एक Peter Shor एक MIT का professor है, and he basically proved mathematically or proved theoretically that these algorithms are can be broken easily if I have been given a quantum algorithm. So the security of the asymmetric algorithm is almost 0. आप ये सोच सकते हैं कि क्या हालत है. And then the security of the symmetric algorithm is just gone down by half. अगर किसी algorithm को symmetric algorithm को तोड़ने में अगर 6 महीने लगते थे, तो उसको केवल 3 महीने लगेंगे. इस तरीके से समझ लीजिए. So this is a problem actually. So these are the typical number of qubits a quantum computer requires to break these algorithms, and this figure is quite interesting also. So you know this Google is making quantum computers, and in 2019 Google came with a quantum computer called Sycamore, and it is having a 53 qubits only, and they run in some arbitrary problem, and that arbitrary problem that Sycamore solved in just 200 seconds. And if the same problem was solved by the classical machine, then it took 10,000 years. यहाँ पे थोड़ा सा स्वैप करना पड़ेगा नीचे ना. The quantum takes 200 seconds, and the classical takes 10,000 years. So you can imagine from this that how powerful is this machine is. And in 2024, Google again came with another machine called Below, and it is having a 104 or 105 qubits. And the power is so this becomes so much powerful that just to solve the same some arbitrary or fictitious problem, the sycamore takes just 5 minutes or 300 seconds. And but for the same problem, if you do on the classical machines, it takes how much? 10 septillion years. Can anybody guess how many zeros are there followed by 1? 10 septillion years. I don't know also, but I know what the context. Even it is the more than the age of the universe in simple. Even it is the time, it is more than the age of the universe. So from that viewpoint, you can say that how much powerful these machines going to be. So RSA is easy, or the security that we use today can be very quickly. So we need to prepare for these kind of serious threats that will be, practicing very soon in the future. No, not at all. Not at all. Yes. OTP and other things. 30 seconds can duration that, and if you can read that within 30 seconds, done. Right. Communication. और machine आपका before that read कर देता है. और but वो useless है सारा. All these protocols worthless against these machines. So powerful. But there are some solutions are already there. The best part is this. So this is again, the another timeline. One of the organizations or a company building these computers. You see here, IonQ, an American company लोगों ने नाम सुना होगा. Microsoft, Google, everybody knows. But this IonQ is building quantum computers, and their quantum computers, they are becoming very powerful. You can see. By 2028, they will be having a qubits of 1024, or they can break easily the RSA algorithm 1024. So by not 2028, maybe by 2030, let's say, if you extend a little bit, but there are good chances that these classical algorithms are no more safe. So we need to find better algorithms. So there are already some whether I'm all right. So yeah. So these are basically the two protocols commonly used to protect against this kind of threats. One is called quantum key distribution, another is called post-quantum cryptography. So we need to, let's say, integrate this kind of solution in our future digital system, then we can quite safe. QKD is basically a little expensive because it works on the principle of quantum physics. So photons generation, photon entanglement, and so on. So, and also it requires a dedicated channel to transfer those photons. So let's say two parties wants to communicate, and there should be a separate channel is required. So for financial institutions, some critical institutions, critical infrastructure are key. And now that these things are being used actually, HSBC uses this QKD and PQC already. And even, let's say, if I say in India, hsbc.in, if you find. So hsbc.in uses this PQC. So this area का मुझे मालूम है, I can give you a couple of examples also. So hsbc.in, I don't know other SBI and others, but HSBC uses this. So their browser जहाँ से जैसे मैं कनेक्ट करता हूँ उसको वहाँ पे एकदम से थोड़ा सा अगर आपको computer hobbyist can find it out easily. It is having the key encapsulation mechanism based on post-quantum cryptography, which is called MLKE. So the QKD is, as we mentioned, it is having some limitations and also it is quite expensive, but it gives 100% security actually. Generally we call it information theoretic secure. So QKD is quite powerful, but it is quite expensive. Rarely people uses this. QQC is very good. It doesn't require any hardware changes because it is classical. Even on our classical machine it can work easily. No limitations. Also there are
लास्ट वाले
standards are
साढ़े
already
छः पे
available.
करो जो 3:30 से 5:30 होते हैं
QKD
ये
is
मना
no
करें
standards.
करने के लिए
But
क्वांटम
QQC standards are there and they are already used. Even India has also developed some standards for PQC and they are also working very closely. SEBI, SBI, so SEBI, RBI, they have already issued the guidelines to all those organizations. So you get prepared yourself for these things actually. So just as I mentioned, this is one of the example of